For experiment 161, spoon bell, they recommend a large metal spoon that's relatively heavy, and that you find a piece of kite string or other string, and that you tie it in such a way that when you pick it up, it's actually balanced. So here you'll see, relatively balanced. I had to shift that knot around to find that point of balance, and then in order to keep it there while the kids actually did the experiment, I've stuck a tiny little piece of sellotape at the bottom. You also need to make sure that the ends of the string are about the same length, and you'll see when William does it how he uses his forefingers to actually touch against each other with full tension on the string to make sure that length is the same. Then in the experiment, you're knocking the end of the spoon against a surface, a hard surface, a table leg, a counter, just tapping it very lightly and then hitting it hard, and then observing through the string, and then your fingers are blocking your ears or onto your ears, how the sound is either softer or louder based on whether you're hitting harder or softer. I will put a little diagram together explaining the theory behind it, but I wanted to understand if, this is an aside, if there would be a difference in the tone of the sound based on the different lengths of the string, and there wasn't. So the tone is produced by the wavelength, which is determined by the length of the spoon, and so I tried a smaller spoon and even a smaller spoon, but these didn't really produce a wonderful sound, but their tone was higher because the wavelength or the tone was produced by, you can see the size difference of the spoons that I've got there. So, but for the actual experiment, all you need is the large one and then hitting it harder or softer.